let's get started. Yeah, today we're welcome everybody actually to the computing cluster. Amy, the normal host, couldn't be here today, so I'm filling in, but I'm kind of delighted to fill in because I have a special connection with you, Howard. I don't know if you remember this, but Howard gave a talk at Phosphor G, what was it, 2017, about Jerry Evenden and Proj.
Yeah. Yep.
Yeah, and
Boston.
Yeah, in Boston. When I first joined the USGS in 1989, I worked I worked my whole career in the same office that Jerry Evenden worked in, and I would go down to Jerry's office and hang out with him. And it was the first time I saw a Linux computer. We had these three computers: Larry Cohen, Larry Moe, and Curly. And he talked about, and he had these little C code, pieces of C code that we were doing transformations with. And at some point, he said, I should make this into a library. And that was the beginning of Proj. And I've just been amazed that the software can last that long. Anyway, I really appreciate it, Howard, that you gave a little kind of a tribute to Jerry Evenden as part of that talk, and have continued the tradition of releasing awesome, high quality public domain software that the rest of us can use. So on that note, today he's going to be talking about COPC. I think, is that the right way to say it?
Sure. Any pronunciation's fine.
Yeah. Right. No judgments. All right. Good. So yeah, I'll just turn it over to you, Howard. Take it away.
Yeah, thanks for the intro. Yeah, COPC or COPIC or COPIC, we're not quite sure. The community seems to be coalescing around COPC, but you'll hear COPIC quite a bit too. That's the English American pronunciation. Of course, there's the French pronunciation, and the Norwegians have a pronunciation. So everybody produces or pronounces acronyms in their own in their own dialect. That doesn't. I don't have a strong opinion about such things. Again, my name's Howard Butler. I've been an active open source geospatial software developer for a really long time. Active in the GDAL project. My company called Hobu Inc. We put out the PDAL open source library that's used for point cloud data processing and management. And I'm going to talk today about cloud optimized point cloud. Some of you maybe have seen parts of this presentation. I gave something on this at Phosphor G last year or 2 years ago, and presented in a few other venues as well. But I'm excited to give it to you guys. So what is COPC? Why would you care? So first off, it's an LAZ or LAZZIP 1.4 file. LAZZIP is a point cloud format that's very commonly used for LiDAR point clouds. And it's used for other kinds of point clouds like photogrammetry point clouds, not so much for sonar, not so much for radar, but it certainly has grown up in the geospatial LiDAR domain. 1.4 is the latest released version of the ASPRS LAS specification. It's a mouthful. Which happened in 2010, right? So it's almost a 13 or 14-year-old specification that LAZZIP is based on. What is COPC doing to LAZZIP? Well, it's adding some metadata, and then it's storing the LAZZIP file clustered according to that metadata. And we'll talk a little bit more about why that gives us some very interesting benefits. Why bother? What is it doing for us? So the most important thing is it allows us to have what's called opt-in spatial access to the data. So LAZZIP and LAS are not formats that are organized for querying for a spatial window. Say you wanted to query just a box, or querying for the data at a specific resolution. So what COPC is allowing is providing what I call selective decompression to a LAZZIP file. And it does this in a backward compatible way, meaning a COPC file is an LAZ file that anybody who has an LAZ reader can continue to read. Some of the upsides of doing this, why we should bother doing this thing, is LAZ already has kind of industry-wide read support, right? So except for a certain geospatial software vendor in Southern California, most of us can read LAZ at least to get the points out, right? To get access to the content. And LAZ provides very efficient lossless compression, and its focus has always been on the idea of a lossless compression. So, it's is straightforward to organize point cloud data in a multi-resolution structure that is lossy. And in many cases, you don't need all of those points. You don't need all of that data. But if you're using a format for what I call archive and transmission, the ability to have a lossless compression of that is really, really important. It's open source. The library, well, there's a couple libraries that are open source that support and implement LAZIP. Those have been recently released as Apache public license, meaning if you want to embed LAZIP on your LiDAR scanner hardware implementation, you're welcome to do so. There's really no impedance software licensing wise to putting LAZIP software wherever you need to. Downsides for LAZ, it's really CPU intensive, and it's kind of slow to compress and decompress. And the reason for this is it has a very complex compression model, right? So when Martin Eisenberg developed LAZIP, his ideas were to use an arithmetic encoder to squeeze as much fluff out of the LiDAR point cloud file as you could. And it was doing this by essentially modeling how LiDAR data move and react together. And so this is important to note that this is really oriented towards what we call linear mode pulse LiDAR, right? So, which is most of the LiDAR today. Your iPhone LiDAR doesn't quite work like that. The space LiDAR like ISAT doesn't quite work like that. A photogrammetric reconstruction from imagery, those point clouds don't work like linear mode LiDAR. So it's not a perfect fit for every kind of LiDAR. But since the bulk volume of geospatial LiDAR, geospatial point cloud content is aerial linear mode LiDAR, it has certainly entrenched itself into our industry. So what LAZ, certainly we have this idea of ubiquity and metadata, and we can compress the data, but it was missing these two kind of key features: the ability to access a file with some sort of spatial window, and the ability to select the data to a depth or to a specific resolution. When LAZIP was constructed and first written in maybe 2006 or 7, a large point cloud file was like 12 million points. Like, I think there's a famous file called Serpent Mound in Ohio that was captured that's been used as a test data set for a long time, and it was like 12 million points. It was a really big file. When Eisenberg was developing LAZIP, he was using LiDAR data to show that it was an efficient compression of his mesh, right? So he was looking for data big enough to show off his technology. Spatial windowing wasn't really necessary. 12 million points is certainly pretty big for computers at the time. But now it's quite common to have, 120 million, 1.2 billion, 12 billion, like really large collections of point cloud data are really common. As the scanners have improved in fidelity, the signal processing has improved in being able to capture and store more of that content. The volume has just continued to rapidly grow. And the only way to kind of keep up with this is to be able to divide and conquer the data. And to be able to do that means being able to select for a window or select for a resolution. Why, we could write any format that would do this for us, but why would we want to use LAZ and LAZIP? The first one is LAZ right now, as of 2023, is the storage and archive transmission format for public LiDAR catalog, right? So if you go to USGS, you're going to download the LiDAR point clouds for 3D. That's going to be LAZ content. If you were to do the same in France or Norway or Canada or Sweden, also, it's going to be bulk LAZ content. So LAZ is already kind of what is used to get the data to someone. There's petabytes of content out there in LAZ. It's well established, and there's a lot of open source implementation for it as well, right? So both commercial and open source software tools can take these libraries, implement LAZ support into their software without having to build it all themselves. And for those of you working in the raster space, cloud optimized GeoTIFF absolutely shows the way here, right? So, COPC is very much intended to be in that same sort of sweet spot where COG is, which is it has the ability to provide this capability, which is for For COGS, it's to be able to provide overviews and range read over the internet, and the same thing for COPC is to do that within the context of an established existing format, where those users of the existing format as is, they don't have to take advantage of this special capability. It's opt-in. That has provided a very large boost to how cloud optimized GeoTIFF works, and it has provided the same boost for COPC as we're starting to see. A little bit more into the implementation detail. So the data structure that is stored to provide this opt-in spatial queries is something called an octree, if you're familiar with some spatial indexing. That octree is organized exactly as what's called entwined point tile, or if you've worked with the POTRI converter, it's the same octree structure as POTRI converter uses as well. But the interesting part is that we also take that LAZ file and we cluster that LAZ file according to the nodes in that octree, right? And so for an application that is looking to scan or pan across data, they can read the metadata, figure out exactly what to read, and then go do a range read over the internet to fetch and decompress only what they need. That's exactly what's happening in cloud optimized GeoTIFF. Although I think cloud optimized GeoTIFF can be a little bit more complex than COPC, but part of our intention was to limit the complexity for implementers with COPC. Specification is open. Go to copc.io. You can read up on the spec. It's really quite simple. Again, it's also 3 specifications, right? So there's the COPC specification, which is the metadata. There's LAZ, which doesn't really have a specification, which is how you compress a LAS file. And then, of course, there's the LAS specification from ASPRS. So it's kind of this stack of specification and software tooling that's built up over the last decade and a half. This all comes from Martin Eisenberg. He developed LAZZIP in mid-2000s. We worked with him to make LAZZIP be an open source software project in 2013. He died this recently in 2021, but his tooling, his capabilities of what he built with these software libraries, they just wouldn't have existed without his input. So what? Why we bother? I mean, even with cloud optimized GeoTIFF, what we're trying to do here is be able to read partial content, right? So I call this data as a service, meaning data sitting at rest can be consumed incrementally over HTTP. That's what you're doing with a cloud optimized GeoTIFF. That's what you might be doing with PM tiles if you're starting to use some of that. The idea that these data files are just sitting at rest, organized for a particular exploitation and data access path. For point cloud content, that means kind of balancing the ability to select points for a given depth of the tree with the ability to compress them very efficiently and not provide data over selection or having to read too much data to be able to satisfy a query. Applications need to be able to control how they interact and query with the data, whether that's panning and scanning over a large file very quickly to provide some sort of context, whether it means reading data for high intensity parallelism, and then of course doing stuff at bulk content, bulk volume. So what can I do with COPC? So right now you can stream it and render it directly in a web browser. So we have it's not open source, excuse me. It's based on Cesium, a viewer that's available at viewer.copc.io that you can point your files at. You have to set up a course thing, but you can use this directly as a renderer in your own applications if you want. Of course, it points to us and our sales thing. Which isn't that much of a sales thing. But anyway, the idea is if you're building big applications and you want to embed something like this, you can reach out to us. It's not open source. But again, when the Cesium application is figuring out which points to select, it's using the metadata in the COPC file, streaming that over the network, and then decompressing it in the browser to satisfy Cesium's point cloud requests. And so we have a little shim layer that kind of does that for us. The same kind of idea could work in POTRI. I know there's a couple of implementations of COPC and Poetry, but nobody has put forward a pull request. If you're motivated, feel free to contact us. But the idea of being able to use these points simply for visualization and context, again, is really important for a lot of applications. We have a website called validate.copc.io that we developed. And the idea here is based on that viewer. The viewer is in there as well. But the idea is be able to essentially drag and drop, plop down your own COPC file, and provide some sort of validation of whether or not we think it meets specification. Of course, if you look at some of the red, green, yellow stuff, some of them are maybe more important than others. It also provides capability of just looking at an LAZ or an LAS file, which is really handy, right? So if somebody gave you this data and you're like, well, what do I do with it? If it's a COPC file, you potentially could just render it and look at it right in your browser. If it's not, you can at least get header information or maybe figure out what its bounding box is, stuff like that. It provides the ability to kind of deep scan a COPC file and make some pronouncement of whether or not it validates and so on. This is all based on open source JavaScript tooling that's available for anybody to go build on, right? So, there's a JavaScript library called COPC.js that implements all of this, and the tooling to build kind of your own thing is available. And, we provide this as kind of a community service for people to go and both look at their files and validate, make sure that they're keeping up with whatever the specification is, which itself is really quite simple. The other nice thing that this both the viewer and the validator provide is local drag and drop file support. So, I think it's really useful to have a viewer for LiDAR point cloud content. And when we first started out doing lots of LiDAR processing, that was always the hardest part. And the most difficult challenge was, well, what does this stuff look like? And, to see the tooling evolve there has been really nice. So what else can I do with a COPC file? One of the things that COPC enables is the ability to select data for what's called a floored resolution, right? So essentially try to satisfy a query that's going to give me data at least 2 meters or better over a particular file. So this is that same SOFI file that we were looking at before. I think it's 360 million full density points, right? So at full density, this file is, really quite large. But I don't need to read it at full density to be able to produce a raster like that, which is just a simple rasterization of maybe I think that's the intensity. I can do that with only 1.7 million points, right? So at much smaller amount of data to be able to read and fetch over the network, and provide a query response to the user. The other nice thing about this is it's convenient and embarrassingly parallel. So if you had a data file stored, maybe it's on your cloud object store, maybe it's stored on whatever your server you have. If you have multiple applications hitting this all at once, there's no server in the mix there besides HTTP. They can hit this thing as fast and as hard as your network system will allow. There's no sort of contention or locking or anything like that needs to happen. Some other COPC implementations that are now available. So LASPI has COPC read support available in it. So if you have COPC files out on the network and you want to be able to incrementally stream those over the network, you can do that with LASPI. LASPI implements LASZIP, of course, and that's kind of the pure Python implementation where everyone maybe gravitates towards. You can't write COPC files with LASPI currently. Of course, PDAL is going to have implementation here. That's kind of the mother implementation. There's a C++/Python library out there called COPC lib that has implementation that you can build on. LazTools is supposed to have COPC certainly read support here in September or October of this year. I'm not quite sure where the implementation is, but the intention was to get that out in at least end of Q3 or beginning of Q4. Safe FME, if you're a safe user, their first or second point release this year implemented a COPC reader and maybe a writer or two. I'm not quite sure. SAFE, of course, had entwined point tile support, so this is an extension of that. If there's any manifold users in the audience, there's still a manifold implementation if you're doing point clouds with that. And then probably the biggest implementation is QGIS. So QGIS allows you to read and now start doing some point cloud processing with both untwine, which writes and creates COPC files, and then PDAL. There's Rust implementation if you're into Rust, and then there's JavaScript implementation, like I said, that all of these other tools are based on and built with. Finally, so what can I do with COPC? I think the biggest, most interesting and important one for us is to, we have implementation of COPC inside of QGIS. And what that means is that to have that kind of keystone implementation is people are able to conveniently create COPC files with their local desktop. They're able to do local desktop GIS interaction, right? Because most of the time when you have a point cloud file, well, the first thing most people do is rasterize it into an elevation model, right? They don't want to deal with points as a point cloud. And so QGIS is certainly the latest release is going to allow people to do that without having to do lots of work. So it's really convenient. The other nice thing about QGIS implementation is these things are streamable over the network. And so if you want to do point cloud data services as COPC files over HTTP, both using QGIS and our viewer, our Cesium-based viewer, this is a viable path for you to essentially provide convenient visualization and interaction for your large data holdings without having to pre-bake, pre-build, stage content on everyone's machines. And so this is kind of, in my opinion, kind of a new approach, new world. I mean, it's not new approach, new world for people who've done raster data for the last 20 years or even some of the vector stuff, but being able to do this in point cloud land is certainly kind of ahead of many of the other software tool stacks that are available. Finally, I need data. So one really convenient place to go get data is to sign up for Planetary Computer. So Planetary Computer, we worked with Microsoft. They actually helped build COPC as part of that effort. And there's like 200 plus terabytes of 3-dep data available as COPC that you could, query and filter with LASPI inside of a Jupyter notebook, or do the same with PDAL, and process out your products and do whatever you might want to with that content. And then finally, and the most important part of COPC is the existing workflows that you've already built with LAZ all continue to work. So as a data delivery mechanism, delivering COPC to people, the price of that is 15 to 30% storage cost, right? Because spatially organizing the data kind of disrupts that model that we had talked about earlier that Martin had developed. But in exchange for that cost, applications potentially don't have to read all the content, right? So especially if they're doing window type access, whether they're a viewer or maybe there's some processing application that's going out there and reading small patches of data and producing content on the fly, you can do those things in an opt-in way. But if your software application hasn't been updated to support COPC metadata and querying that particular query pattern, you don't need to do that. You can still just read it as an LAZ file. And so that means existing tooling like white box tools or Cloud Compare or any of the applications that have LAZ support in the commercial realm can continue to read COPC files and do just like do whatever tasks they were normally doing with them. That's the same pitch that Cloud Optimized GeoTIFF makes. It's the same sort of magic trick that makes Cloud Optimized GeoTIFF get traction, in my opinion, over some of the other streamable raster data formats that are out there, is this idea that I can go take an old GeoTIFF and go read it in Photoshop if I absolutely had to. I don't know what the equivalent of Photoshop is for LiDAR point cloud content is, but certainly stuff within the last decade, you could still read COPC files with those. Kind of a current roadmap. This is maybe a little bit old, but just mostly the interesting thing here is seeing that implementations are either available or on people's queue to get developed, and providing kind of this sort of ring of software implementations that all support each other. The big ones, of course, are PDAL, QGIS, having JavaScript support for people to build applications with, but all the other ones help as well. And, as more software tooling implements it, both for convenience and for support of other activities like the various data archives, essentially hanging their data on the internet as COPCs, like NR Canada recently did. That also provides more incentive for more implementation. So it's a cycle that, or a flywheel that takes a while to get spinning, but eventually it starts to gain some momentum, as it's shown to be very useful. Big takeaways from my particular slide deck here is, it's an extension of LAZ. It's backward compatible, and it's only LAZ 1.4. So LAS has 5 kind of subversions. To kind of lessen the surface area for software implementers, COPC only says LAZ 1.4. For most of the data catalogs and warehouses that are housing LiDAR point cloud content, this is perfectly sufficient. People can up-convert data if they needed to. The software that implements LAZIP was recently relicensed to Apache public license. That might have meaning. That doesn't have meaning for most folks, except for the people looking to embed LAZ support in some hardware implementation. Maybe you want to put LAZ on an iPhone and capture your LiDAR point cloud that way. You have no restriction of doing that now. There's plenty of open source and otherwise commercial software implementations that are either becoming more available, and it's been interesting and great to see this particular effort continue to grow. COPC is part of a larger sort of, I guess the trade winds of geospatial are certainly blowing towards some of these other approaches to how do you deal with these really massive collections of data. Point cloud has always kind of been a niche of that. Most of this effort has been evolving in what I would call raster land, but cloud optimized point cloud, I think, also certainly was designed and implemented with the idea that it would continue to be fruitful and useful in this niche for an implementation. And the sort of keystone of that is the idea of stack or spatial temporal asset catalog implementation. And we've been doing our best to contribute to this in a number of ways. On the data side, we worked, as I said before, we worked with Planetary Computer. We also managed the USGS 3DEP public data set on AWS. And so there's like 300 plus terabytes of LiDAR point cloud content there. That's as entwined point tile instead of COPC. They're kind of both each side of the same coin there. We maintain a stack catalog of that 3DEP content that's generated every night as the data is captured and collected. We've implemented a driver in PDAL called readers.stack, which then can consume that item collection or catalog to dereference those files, and there allow you to query for, say, a bounding box or some of the kinds of stack properties that you might select data for. And then we also supported the development of a similar driver in GDAL called Stackit, which allows you to kind of do the same thing with raster content and essentially turn that into a VRT. One of the other things I'm missing on here, I guess, is there's something called QGIS virtual point cloud format. The QGIS virtual point cloud format, we developed that. Those are just stack items in a collection. So just a list of stack items. So the nice thing about that is if you were to hang those on some network endpoint as a VPC file and they were all relative file paths, you could use that with your normal stack reading, writing software. So that's another piece there. And then, of course, specification wise, we wrote the COPC specification. So this is, some of our recent activity here in the last year and a half. Again, trying to make sure that point clouds aren't left behind as far as the implementation of all these awesome tools and processing approaches to really big geospatial data. that's all I really have for prepared content. Happy to take questions or shoot the breeze or whatever. But thank you very much for the opportunity, and hopefully you got something from this.
Awesome. So if you have questions for Howard, you can go to reactions and raise your hand. And I do realize that I've kind of jumped the gun on Howard's presentation. I was supposed to do news and announcements for something first. But we'll do that after though. So let's have some discussion here. I know that many of my questions that I had along the way, I was like, and then you answered them, Howard. So I was particularly interested in the stack connection there. Maybe I'll just kick it off though, since I don't see a raised hand. You made the analogy to cloud optimized geotiff, and in cloud optimized geotiff, we often see like 512 by 512. There's sort of like a default, that almost everybody ends up using. Is there sort of a similar thing with the COPC data? Is there like a attempt to sort of optimize the to make sure that the chunks aren't too small, or maybe the chunks are small for visualization? There's this sort of trade-off, I guess, between the chunk sizes for like analysis and visualization.
There is, although it's not as strong as the raster stuff is. So because point cloud files aren't equal density everywhere, it's a little bit harder to say, here's kind of what we want for a chunk size. Eisenberg actually, when he developed LAZ, had done some experiments to try to essentially find out how many points at which his encoder model starts to essentially model as noise instead of provide him modeling benefit. And it depends kind of on the dimension that's being modeled, but he ended up at about 50,000 points. And so 50,000 points is a megabyte-ish sort of chunk or something like that, usually for typical LiDAR point cloud. And so that's kind of what we would try to target, but that doesn't mean every chunk is 50,000 points. And you want to balance, you don't want to break the data up too small. I mean, you get lots of selectivity that way, but you end up making lots of requests. Same thing with COG. But you don't want to make it too chunky either, or otherwise you end up kind of overfetching data. If your COPC data is getting used for processing a lot more than visualization, then you would want it to tend to be more chunky. If you're doing it for viz, you would want it to be busted up a little bit more. But that gradient is pretty wide and is really sort of related to the density of the LiDAR point cloud itself more than how big an area you're viewing. So, for QGIS, I don't think we've even exposed the options for people making COPC files with QGIS to be able to control that chunking, and nobody's really complained yet. And so I think a lot of that has to do with, on a local file system, you don't even feel it. Over the network, you feel it a little bit, but most of the viewers are fetching content in parallel anyway. So you can certainly saturate a line. It's definitely a consideration. There's plenty of research if somebody wants to go find the perfect curve, but we haven't to date and haven't really needed it.
Right. Well, that's nice. Okay. Well, I had another question about the compression. So there's just one compression scheme. It's not like sort of a pluggable thing. Is that right?
Correct.
Yeah. Okay.
And so I've been playing around recently. So I added Arrow and Parquet support to Poodle. So the next version of Poodle that's being released here, hopefully in a couple of weeks, we'll have Geo Arrow and Geo Parquet support. And so I've kind of been playing around with those in terms of, well, we could do the COPC thing with those too. It's not COPC in the sense that, well, you still have to find somebody who's implemented Arrow support for your tooling to be able to read the content out, right? So COPC has the COG thing going on for it. But, for people doing Arrow ecosystem, like there might be a really strong benefit to doing that sort of thing. We don't have funding to build that out quite the whole way, but if you're interested in funding, contact me. But the concepts certainly apply to stuff like that. There isn't probably ever going to be opportunity to evolve the encoder of LASZIP. And a lot of that has to do with Eisenberg and how he wrote it. It also has to do, I think, with just kind of the evolutionary dead end that LAS is. It's not a generic point cloud container for everybody. It can be used that way in a not convenient fashion, and some people do that, but LAS 1.5, which is an effort that's currently underway, is the big features there are well-known text coordinate system metadata and preventing the loss of GPS precision, right? So the things that the evolution of the format are going to improve are quite minuscule and maybe a bit niche. And so point cloud community certainly can build its own custom formats that do these same things probably more efficiently, certainly behave in faster and work with different tooling. It's just they have a lot of trouble like having the same sort of ubiquity position that something like COG has, which COPC does.
Okay. Anyone else with a question? Well, I have one more question. If we go to Planetary Computer, I've been there. I haven't been there recently. I haven't looked at point cloud data there. Are there notebooks, or maybe this is, I think I saw Tom on here, but if you don't know the answer, maybe Tom knows. Are there notebooks that we can find that sort of show, that start off with a stack query, do some processing? Okay, cool.
Yep. There's definitely a notebook there will do that. I think it goes and selects data around the bean and Centennial Park in Chicago. And we'll kind of get you started there.
Yep, Tom dropped the link there. Cool. Okay.
And since we're certainly a little bit early before the news, if anybody has Poodle questions or other sort of stuff I'm active in, feel free to take advantage.
Okay, I had one little, just a minor last question. When you say we haven't been funded, is the we the royal we, or do you have
we is the Hobu team? So we do those kinds of things, but we don't have specific directed funding for doing spatially organized, sparse COPC support, COPC like support in Aero or Parquet. I mean, we are not currently funded to do such a thing, but it's sitting there, and it would be straightforward to implement.
All right, Amy is here. Yeah, sorry. Go ahead, Amy.
No, it's okay. I'm at the airport. Can you hear me okay?
Yeah.
Oh, okay, sweet. Yeah, I had a couple questions. The first one was just, would you like to see wider COPC adoption with larger Earth observation data providers, and why or why not? And what do you think are some of the barriers in doing so, or challenges?
I think it depends on the data niche that's active. So like if your data niche is aerial LiDAR, COPC is a perfect fit. If your data niche is something like ISAT, I think there's some utility there in terms of like providing, for ISAT, for example, it'd be like, well, I'd really like the ATL03 data as a point cloud that I can swim around in. But that's not what people mostly do with ISAT data, So it's not necessarily a perfect fit for every niche. I think it's a great fit for if you're the national agency of wherever and you're providing the LiDAR point cloud for your country, hanging it on some HTTP server in COPC is exactly what it was designed for. If you're building big data processing applications based on, say, you're doing the forestry application of LiDAR, it's also a great fit for those kinds of things. If it's, like I say, linear mode LiDAR, that's where we're seeing most of the adoption happening. That's where we're seeing a lot of the uptake. Again, the uptake happens where it's convenient for people to view data. That's sort of been my working assumption. And so again, most people's interaction with a point cloud file is to turn it into a raster as quick as they can. And so, being able to do point cloud processing and point cloud visualization with existing tooling, I think, is a really important driver of implementation. And so that's what we've been doing with the QGIS effort.
Okay, yeah, that's helpful. So like you said, swim around in, do you just mean sort of like visualize?
Yeah.
Yeah, okay. Yeah, because we've also been obviously looking at GeoParquet and Flat GeoBuff as potential cloud optimized formats for point cloud data. But it sounds like all three could support large scale like parallel processing. It just sort of depends on what your application is, which one you might select.
Yeah, so like a geo arrow file of a common file that I use for testing is 4 times larger than an LAZ and a COPC file. So in exchange for that, it's much faster to access it. So if you're willing to take the 4x hit, you potentially can read it much faster. There isn't the same sort of spatial indexing structure, at least for GeoArrow, that's available yet. That's something to be discussed. But there's, as always, there's these trade-offs.
Yeah, that's an interesting example. So you're saying takes longer to write the COPC file, but it's faster to read.
Yeah, and you would just have finer grain control over it. So, if you're like a big archive, and you want to hand off, you want to hang as a small file as you can within reason, but still allow people to take advantage of the work you've done to organize and organize, I mean, spatially organize that data and sort it and organize and write it to disk so people can stream it. That's a great way for them to get advantage, and not have to redo the same sort of work, which is I take a big point cloud and the first thing I do is I convert it to a big octree so I can select for a window or a resolution. I mean, that's the beginning. That's step 0A for most point cloud processing tasks.
Okay, that's helpful. Thank you.
Okay, Jim Call.
Yeah, I think my questions are sort of along this line, but you've referenced a few times that this was primarily for linear mode pulse LiDAR. Is there a reason you wouldn't use OpenDroneMap? I come from the structure for motion side of that world. So is there a better format, or are you saying that we should just be storing those like this?
So OpenDroneMap, Piero was one of our first implementers at COPC. So like that, there's connections and relationship there. What I mean by linear mode LiDAR is the LAZIP format itself, the encoding model, which is kind of the modeling of how different attributes like say GPS time or return number or intensity, how they would essentially go up and down or change in value as the file is kind of written to disk. And that model very specifically is tuned towards linear mode LiDAR. That doesn't mean you don't get benefit from LAZIP on just normal XYZ or XYZ intensity point clouds from something like OpenDroneMap. It's just you don't get as big a boost. And so if that's what you're using it for, I mean, it's no problem to keep using that. And again, the benefits are, somebody can read the file. So that's why you might you might choose COPC or LAZ over something like a PLY file or an OBJ, mostly because you can transit the geospatial coordinate system information, and you can't really do that with those file formats. And so again, it's always these trade-offs that you have to make.
Thanks. That makes a lot of sense. Yeah, thanks.
All right. Any last questions? Anybody else? I think Amy's hand is still up. Is that right, Amy? Or do you have another question?
No, I need to lower it. Sorry.
Oh, that's okay.
Thank you very, very much for the opportunity. Like I said, Poodle 2.6 is expected to be released here in the next couple of weeks, I hope. releases are always sketchy, but we're certainly heading there. If you have anything hanging out that you want to get addressed in that, maybe make a pull request or make a ticket. And again, thank you for the opportunity to talk to you.
All right. Well, thanks again, Howard. Thanks for this talk and for your contributions to the community. They've been amazing. All right. Let's switch mode to announcements. We're going to switch over to take a look at the Google Doc there, and let's see. So there's a note there. Actually, well, okay. So I have an announcement that just if you aren't aware, the Pangeo Showcase talks are going on again. They started last week, and if you go to that page there, you can see all the talks. Get to the recorded talks. There's a talk this week, day after tomorrow at 4 p.m. Eastern. Martin Durant is talking about intake 2, the future. So it's a chance to kind of hear what Martin is thinking about for intake 2, and maybe weigh in with what you think would be important features to have. So with a discussion with Martin. So I think that'll be pretty cool. And then I see Amy dropped in the link to the there's the Pangeo Discourse Forum post on Cloud Optimized Point Cloud, where you could also continue the discussion. Anyone else would anybody like to announce anything? Megan, do we have any ESIP announcements that we should know about?
I think it's probably been shared multiple times, but we are recruiting now for our next round of ESIP Community Fellows. This is a really wonderful opportunity for graduate students and recent postdocs. It's how we found Jim and how we found other, awesome connections in the past. So if you know of anyone along these lines, please forward them send the link in the chat to them. And this is a great way to bring them to the ESIP meetings and help them get embedded in clusters like this one. So if you have any questions, let me know. The deadline is in early October, so it's coming up.
All right. Thanks, Megan. All right. Well, it's 1:51, so we get 9 minutes back in our day. Thanks, everybody. And Amy, hope to see you back next time in the host role. All right.
Thanks, Rich. Thanks so much. Thanks, Jim.
Thank you.
Thanks, Howard.
Thanks, Howard.